This is section 1.4, perimeter and area in the coordinate plane. So today we're going to be talking a lot about shapes. So polygon. A polygon is a closed figure formed by 3 or more line segments. A convex polygon is one where you can't draw a line along one of the sides and have it go through it, so it doesn't have a piece that juts in. A concave polygon does have kind of a piece that juts in. It looks like you took and cut out a piece of it. So that's just some vocabulary. Naming polygons, you guys should know some of these. If it has 3 sides, it's a triangle, 4 is a quadrilateral, 5 is a pentagon, and so on and so forth. Once you get past 12 sides, you just call it so if you have 13 sides, you're going to call it a 13-gon. If you have 20, you're going to call it a 20-gon. Hopefully we're not going to get that high, so most of the time we're going to be working up through maybe nonagons. All right, when we are finding perimeter and area in the coordinate plane, this is where our distance formula is going to come in handy, the distance formula we learned in section 1.3. So how we're going to find perimeter and area, we're going to graph the points. I want you to state whether it's concave or convex, and then we're going to find the perimeter and area in this case. So we're going to do the first example. I have already graphed it here for us. So first thing, we graphed it, check. Now let's talk about whether it's concave or convex. Okay, this one is convex because it doesn't look like we cut into it. So it's convex. And now we're going to try to find the perimeter, and then we're also going to try to find the area for fun. So 2 of these sides are super easy on this triangle because we can just count. So looking at EF, it's just 1, 2, 3, 4, 5. So I know this side length is 5. DE is 1, 2, 3, 4, 5, 6, 7. Awesome. And for DF, we can't count. So that's where our handy-dandy distance formula comes in. So DF equals big square root. So remember, it doesn't matter which order you do the x's and y's in, as long as you just do them both. So I'm going to have D be x2, or 0.2, and F be 0.1. So x2 is -3, minus x1 is going to be 4, plus y2 is going to be 2, minus -3 squared. So -3 minus 4 is -7 squared, plus -2 minus -3 is 5 squared. So the square root of, we have 49 plus 25 equals the square root of 74, and I'm just going to use a calculator, round it to like 2 decimals. Let's go 2. So the square root of 74 is 8.60. So this side is about 8.60. We're not done. We only found that side, so now let's find perimeter. Remember, back in middle school, perimeter is the distance around the outside. So 7 plus 5 plus 8.60. 7 and 5 is 12, plus 8.60 is going to be 20.60. So there's our perimeter. To find the area, remember, the area of a triangle, base times height divided by 2, and your base and your height have to be perpendicular. So look, these are perpendicular right there. So we have 7 times 5 divided by 2. 7 times 5 is 35 divided by 2, which is 17 and a half I forgot labels. We're going to label the perimeter as units. And area is going to be units squared. This might become a little bit more tedious or difficult if you have a quadrilateral and none of your lines are straight, horizontal, or vertical. So you might be doing 4 distance formulas, but that's just more practice for you. So remember, perimeter, area, you need to